Hello and welcome to Chapter 3, Section 5, Exponential and Logarithmic Models. The 5 most common types of mathematical models involving exponential functions and logarithmic functions are as follows. And I added a 6th one that we'll see. So at this time, pause the video and copy this information down. Next, you'll see the basic shapes of the graphs of the functions from the previous slide. Exponential growth, exponential decay, Gaussian model, logistics growth, natural logarithm, and a common logarithm. Again, if you want to copy these down, stop the video and copy them down. Now let's look at some examples of how to use some of the formulas. First, we're going to start with completing the table for a savings account in which interest is compounded continuously, and that is the formula A equals P e to the RT. Okay, so let's start working with our first one. We have an initial investment of $750, an annual rate of 10.5%, and we want to find the amount after 10 years. So let's plug into our formula. So we don't know the amount, but we do know the initial investment, and that's the principal, P. So that's 750. And we know we have our E, and we know the rate is 10.5%, so that's 0.105, change to decimal, times the time, which is 10. Okay, all we simply need to do is plug this into the calculator and round it to 2 decimal places because we are working with money. So we plug all that in the calculator and we get A equals $2,143.24. Okay, so that's our answer for right here, $2,143.24. Okay, we also want to do one for doubling. That's how much time it takes to double. Well, if we double our initial investment, that means that my A would be $1,500. And that's going to be equal to my principal, which is $750. E, my interest rate is still 0.105, and what I don't know is T. Well, I start out by dividing both sides by 750. And I get 2 equals E to the 0.105 T. Well, I need to get rid of the T, so I know I do the ln. So that's ln of 2 equals 0.105 T. So that means the last thing I need to do is divide by 0.105. So T is approximately 6.6 years. That's the time it takes to double. Okay, let's look at our next problem. We have an initial investment of $10,000. We don't know what the rate is, but we know the time to double is 12 years. So we can do that one. Again, plugging in the same formula, and that's going to be 20,000, because that's 10,000 doubled is equal to 10,000. E, and the R we don't know, but the time we know is 12. So we divide both sides by 10,000. And we get 2 equals e to the 12r. We do the ln of both sides. So that's ln of 2 equals 12r. Divide both sides by 12. And we get r equals 5.8%, approximately, of course. So there's our rate, 5.8%. Okay, using that information, we can now plug into our formula to find out the amount after 10 years. So we go A equals, my principal again is 10,000, and that's E to the RT, well, 0.058, and our time is 10, excuse me, I got lost for a second, 10. So that's going to be A equals 10,000 E to the 0.58. And all we have to do is plug that into our calculator, and A equals $17,817.93. Okay, we have one final example. Okay, this time we don't know the initial investment. We know the annual rate is 2%, and the amount after 10 years is $2,000. So we have our amount, that's $2,000, is equal to the principal times E to the 0.02, the rate, and the 2,000 is after 10 years, so that's times 10. So we know everything but the P. So that's 2,000 equals P, E to the 0.2, and all we need to do is divide both sides by E to the 0.2. Okay, and that tells us that P is going to be equal to approximately, again, $1,637.46. Okay, that gives me my initial investment, $1,637.46. Okay, the last thing we need to do is find out how long it takes to double. So we have my double amount, which is $3,274.92, and that's equal to my initial investment of $1,637.46. E to the 0.2 T. Okay. I divide both sides by 1637.46. That gives me 2 equals E to the 0.02. I think I made a mistake. T. That's 2%. Up here that was 20%, so I need another 0 in there. There. Now I'm just ready to do the ln of both sides. So that's ln of 2 equals 0.02t. I divide both sides by 0.02, and I get t is approximately 100. I apologize, I made a mistake on my calculations. This is t equals 34.66. So my answer here is time to double, 34.66 years. Okay, that's it for this one. We have one more example. Okay, we're going to complete the table for the radioactive isotope. Our first isotope is 226Ra. The half-life is 1,599. And we want to find the initial quantity. Well, we use our formula. 1/2 C equals Ce to the kT. Okay, we see the first thing we need to do is get rid of our C's. So that's going to be 1/2 equals E to the kT. And now we need to get rid of the E. So we have ln of 1/2 equals kT. And now, which is ln of 1/2 of 1599K, because we knew the time to double in years was 1,599. So now we divide both sides by 1,599, and we get K equals ln of 1/2 over 1599. We're going to leave it like that because now we need to plug back in, because what we wanted was the initial quantity. So we know after 100 years we have, after 1,000 years we have 1.5 grams. So that's 1.5 equals Ce to the ln of 1/2 over 1599, all of that times 1,000, the number of years. Okay, so that gives me C equals 1.5 divided by E to the ln of 1/2 divided by 1599 times 1,000. Okay, we plug all that in the calculator and we get C equals 2.31 grams. Okay, now we're going to do the last example. We start out with our formula, 1/2 C equals Ce to the K times, and our half-life in years is 5715. And first thing we want to do is get rid of the E's. Well, we already know we got rid of the C's. Now we want to get rid of the E, so we're going to have ln of 1/2 equals 5,715 K. Well, we divide both sides by 5,715. And we get K equals ln of 1/2 over 5715. Now we want to leave it in that form, so when we plug into our equation, we'll get our answer. So y is going to be equal to 3, that's our initial quantity, so y equals 3e to the ln 1/2 divided by 5,715, all of that times 1,000. Okay, all we need to do is plug that in the calculator, and y equals 2.66 grams. And that's it for today. Thank you. Bye.